question, he said, why we don't have our own degassing technology? I'm working on one. If I get a chance, we patent it, then we offer it. It's just too busy. So before then, we have to use somebody else's technology until we have something. What we do in the sulfur pit normally, but it's not degassing. We provide a ductor. We sweep it with air, so we grab some of the H2S as possible, because you cannot just leave the pit without sweeping the H2S. You keep releasing the H2S, but it's not a real degassing. Real degassing, we have to use the process. We try to, have our own process for degassing. So I'm working on it. Hopefully by next year, this time, we will have something. Okay? Okay, we have a technology for oxygen enrichment. Any of you remember I said that we revamp the sulfur plant? I said that sometimes we revamp the sulfur plant. Why we revamp the sulfur plant? I want everybody participate so don't fall asleep. Michelle?
To meet the new requirements by government?
No, if you want to increase the capacity, you remember somebody has sulfur plant, right? They produce 100 tons a day. Okay? They need to increase the capacity by, let's say, 120 or 150. Should they go build a brand new sulfur plant? They can modify the sulfur plant. And we have a technology for that. We call it oxygen enrichment. This technology is between us and a company called BOC. Okay, the technology called SURE, just like we say SURE, S-U-R-E. Why BOC? BOC provide the burner. When we use oxygen, at that level, we have to use BOC burner. For those you are working on Chevron enrichment, we are modifying 3 sulfur plant. The sulfur plant is Worley Parsons design 30 years ago. Somebody asked about corrosion. Our unit doesn't go away. Refinery get tired of the unit, but unit is still working. Our unit lasts 30, 35 years. Very reliable. And that's why they don't want to just demolish it, and they like to modify it as much as possible. We are modifying 3 sulfur plant for Chevron enrichment to oxygen enrichment. And they're all designed by Worley Parsons 30 years ago. Still working, in operation, no problem. Everything is fine, except those we have to change to meet the additional capacity, then we have to change it. Okay? That's why we call it oxygen enrichment. What we achieve with oxygen enrichment, for the higher recovery, if it's a brand new sulfur plant, somebody wants to do oxygen, we can do that. But the equipment is smaller, and I explain why. And because we are using oxygen, the temperature automatically is higher. You remember I said we use air? I showed you the air blower. But if you use pure oxygen, what does that mean? Those are not chemical engineers. Just a simple word. It's a higher concentration, right? So the temperature is automatically higher. So we have a better ammonia destruction and everything. Okay? So oxygen has a lot of advantage. Let me show you. Also, we use oxygen for other reasons too. It's not only necessary to increase the capacity. In some cases, we get the application that the gas is very lean Lean, for those who are not chemical engineer, when the H2S concentration is not very high, we call it lean gas. And again, as gas is very lean, we have difficulty with the combustion temperature. Because H2S with oxygen, if its H2S is rich, the temperature is higher. When you have H2S lower, then the temperature automatically lower. It's just a very basic knowledge. So for those cases, we have very lean gas, we rather to use oxygen or rich air. It doesn't have to be pure oxygen. At least we can enrich the air. Those you are not, again, a chemical engineer, the normal air that we breathe, like everybody breathes, has about 76-77% nitrogen, about 21% oxygen, and the rest is like a water, right? So when we use air, bring it to the sulfur plant with the air blower, all really we are getting 21% oxygen. What is the rest? It's just a junk, right? Nitrogen doesn't do anything. Nitrogen is an inert gas. So why we do that? We just take the space, take the volume. It's useless. When we enrich the air, what we do? We replace basically nitrogen with oxygen. So we make it more useful. Okay? So that's called enrichment. So we can enrich air by any percentage that we want from air all the way to 100%. We get to the point, we just cut the air out. All we do, we get it 100% oxygen. And we can operate the sulfur plant with 100% oxygen. But it's not required. We cannot just switch from air to oxygen. There's a lot of limitation on temperature. There's a lot of control system has to be changed. It's not easy. It becomes another technology. Who licensed it? Us and another company, that's it, around the world. You remember you asked me how many companies does sulfur? I said 4 or 5. When it becomes to 100% oxygen, become 2. Yeah, some other company can do oxygen, the other 5, but to some level. If you look at their capabilities, you say, okay, we can offer mid-level of oxygen. We cannot go higher than that because we don't know what to do after that. But we can go all the way to 100% oxygen according to this technology. Okay? I just want to give you some background what this oxygen means. When we use oxygen, there's a lot of safety required. First of all, you can get air, right? Air is free. But when oxygen, you need to buy oxygen plant. Or you can go buy oxygen. There are companies sell oxygen. They can bring a tankage of oxygen every day or every 3 days. What they do, they bring equipment, like a mobile equipment. They install it at the refinery near to the sulfur plant. And every 3 days or whatever, they come and fill it out. Some refinery, they don't want to spend money to build the oxygen plant. They just buy the oxygen. They get the oxygen company just deliver it to them. They buy it, depending on the location, it's $50 per ton, or, it varies from $45 to sometimes $80 per ton. It just varies. If somebody is a remote location, the company charges so much to deliver it. But some people do that. So when we get a project, the owner says, oh, don't worry about the oxygen. I supply the oxygen to you. I get it. It's my problem. You assume you have the oxygen available. You tell me how much you want, I buy it for you. So that's the basis. Normally they don't ask us because we are not the licensor of the oxygen plant anyway. Somebody else is. So all we get the oxygen at the battery limit and we use it for our design. This is a very simple formula that I said that when we just breathe regular air, we have 21% oxygen, right? We can enrich the air to oxygen. So when we do that, see, as much as we enrich it, we can double the capacity. When we use 100% oxygen, we can double the existing capacity of the sulfur plant to double. And it's very good, right? Very good. It's a very cost-effective option for a lot of refinery. They don't want to spend. If somebody has 100 ton per day sulfur plant, they need another 100 ton. They have two options. They can modify it, or they can go build another one. But modify, you know that modifying is always cheaper than build a brand new plant. Because sulfur plant, you know, I showed you the configuration, but if you count all the equipment in detail, there are 26 pieces of equipment in sulfur plant. If they want a brand new sulfur plant, they have to buy 26 pieces of equipment. But if they want to modify it, it's limit them to 3 or 4, or, you know, depending what equipment is a bad shape or good shape. So by comparison, you can figure it out. It's much cheaper. But they have to add the oxygen cost because they have to buy oxygen. Even though when they add it up together, it's still cheaper. Okay, we said we use oxygen. It's not easy to use oxygen without modifying the equipment, especially where? Remember in the reaction furnace we talked about the temperature is already hot? Okay, I said that we use refractory and a brake and everything. You remember? Everybody remember, right? Okay, when we use 100% oxygen, the temperature is 5,000 Fahrenheit. What are we going to do? Better refractory? No. Doesn't exist in the market. Better brake? No, doesn't exist. What are we going to do? We had to come up with a process to do a staged process. Okay? We do some reaction, hit 3,000, stop. Put another equipment. Cool it, warm it, cool it, warm it. We call it a staged. Why? Because there is no process in the market. I patented process, they can do it in one stage. The patent is just granted. It's not commercialized yet. But if you do commercialize it, it solves that problem. It's not commercialized yet, but the patent is just granted. It hangs in my office. If you get a chance, come on and look at them. But there is no material in the market that was able to do that. And I came with a configuration to cool the system at the same time, so I can control the temperature. Again, a lot of people are interested. We are afraid to offer it since we haven't tested yet. So it's not easy just to offer it. Okay, what this picture shows, that's exactly what I told you. We use different oxygen percentage. We calculate the capacity, but hit the temperature. We cannot go all this higher than 3,200. Or it had the refractory limitation. You see that? Refractory limit is right here. Right? So nobody can do anything. It's the control system. Don't need that. I'm going to show you. You see how all the control system, how complicated it becomes when you use 100% oxygen? Very complicated. You have to understand all this signal and everything. I'll show you how you do it now. Okay. That was existing sulfur plant, right? We talked about it, right? Assume one of the jobs we have in the office. Somebody comes and say, hey, I want you to double my capacity. What are you going to do? I say, okay. You remember we had I keep saying little. We had a burner here, right? Originally, when we designed the sulfur plant, right? Well, we removed that burner. We don't need that burner, okay? We buy a new burner, we call it oxygen burner. We put it right here, okay? This is our ammonia gas. that we talk about, it comes from sour water stripper. This is our amino acid gas. You remember two knockout drum we were showing? I'm not showing it here to simplify it. This is oxygen. What happened to the air? We eliminated the air, right? We said we buy oxygen. Okay. I buy a new burner. I design a new reaction furnace. I design a new waste heat boiler. And I split the oxygen. Part of it to this one, part of it to this one. Okay, what we do between? We control the temperature here. When it hit 3,000, we stop. We stop the amount of oxygen. We said, okay, we give 10 pounds here. When it gets to 3,000, for instance, we stop right there. We don't want to damage the refractory. What we do, we put the rest here. And those are existing. So you can see that when somebody has existing sulfur plant, by adding 3 new pieces of equipment, assuming those all pieces are okay, in a good shape, after 30 years doesn't damage or whatever, we evaluate all those, okay? We add these 3 pieces of equipment, we double the capacity. And this is patented technology by Worley Parsons and VOC. If somebody doesn't have room to add all the equipment, refineries are very old, right? Very old. They are so congestion. We cannot just go add 3 pieces of equipment. No room. We have cases, people come and say, hey, you want to add 3 pieces of equipment? I don't have any room. We say, fine, don't worry about it. What we do, you remember these pieces? We remove these 2 pieces that was existing. We combine it all together, we call it compact. We say, don't worry about it, we fit it there. We have many applications. We've done 45 plants. Near 50 now, I didn't add all the new ones. Near 50, we modify them to oxygen. In some cases, we used previous configuration. If they had room, we added these 3 pieces of equipment. If they didn't have room, we used this one. We told them, don't worry, we fit it there. Whatever it takes, we fit it there. It's a compact design. The other one is normal design.
Can you use the old one, the parts of the old one, or is the old one just thrown out?
Well, if you use the previous configuration, we use the old one.
No, I mean for the new.
For this one, no, because
Enough room.
no, there's no room. Somebody has to accept that if they don't have room, they cannot have everything. Right? So we pull out those, we pull it out, and we combine them. Still there is 2 pieces. Still there is the same problem. But what we do here, if you look at here, some part of the oxygen goes here. You see oxygen here? Some part still goes here, but it's all inside of each other. Call it compact design. It took us a long time and effort to design all this. Don't think it's easy. This piece of equipment is very complicated to design. Our heat transfer group spend days and days before they send it to the vendor manufacturing to fabricate it. Very difficult. You have to meet all the temperature, all the requirements. It's because it's 2 pieces inside of each other. Okay? Those you see is not a normal nozzle. It's lances. We call it oxygen lances. It's a special lance we have to design and put it in so they can insert oxygen. Very complicated. Not simple design. We have in operation, near 50 of them. Works fine, work perfect. Meet all the requirements, all the guarantees, all the performance. Yes. How long have they happening? The first one we designed was about 15 years ago. Where in Japan? The very first one. Becomes like that. Remember? So we deleted all these two pieces here. Everything become like that. These are all existing. So they get this, everybody happy. If they have limitation with the plot space. Okay? But if somebody has two sulfur plan, they want to modify it. We can do many ways. We can independently modify each one of them, or we can do a common one. We thought about every option, right? When we do a patent, you have to think about any possible things anybody want to do. We have application in Louisiana. There are two existing sulfur plants. 10 years ago, they wanted to convert every single one of them independently. So each one got its own reaction furnace, its own burner. But we have units, some other places, even in the US, they don't want to spend all this money, but they want to convert both of them. So the new part, we made it common. The new part, we made it larger to serve two sulfur plants. Okay? Can see that. We put the new one, serve two units. It can go to that one or it can go to that one. And those are the advantages that we talk about of the burner. That was the one I mentioned that in Japan, the first one was 1990. Called Koa Refinery. People have been in Japan, perhaps they recognize the name. Again, the advantage, as we talked about, there are many advantages. It shrunk the equipment, increased the capacity, it's a better ammonia burning, has many, many advantages. When the operator learns how to use, the operation of oxygen is different with the air, but we teach the operator how to operate it. When you start the sulfur plant, they cannot jump, open the oxygen line. They put everything on fire if they do that. They have to start with air. When the unit gets a stable operation, gradually open the oxygen. They get instruction how they have to open the oxygen line and how they can increase the capacity. When they want to shut down, the same thing. They gradually shut down the oxygen. They go on air. You cannot just shut down the oxygen, shut down the sulfur plant. Okay, I'm done. No, it doesn't work like that. You gradually shut down the oxygen, go on air operation, gradually reduce your capacity on air operation. Just cut gradually. You cannot shut down sulfur plant immediately. You have to cool it slowly. If you cool the sulfur plant immediately, you damage all this brake. Okay? We tell them how many degrees per hour they allow to cool it. Okay? There are a lot of procedures to heat up this brake and a lot of procedures to cool it down. We do all this as a licensor. We provide all this information. And we train the operator. We have 2 persons in a sulfur group. They go training. They show exactly to the operator how they start up the plant, how to operate it, how to shut down. There are temporary shutdown, there are permanent shutdown, there are long-term shutdown, there are maintenance shutdown. Everyone has his own procedure. We provide all this information. We get a lot of call for troubleshooting. Oh, I went to do that, this happened. What am I going to do now? Can you send somebody over? We get a lot of questions. Oh, I went to do that, all my sulfur land blocked of sulfur. Everything is solidified, I cannot do anything. Everything is plugged. What am I going to do now? We get a lot of questions like that. We provide all the troubleshooting and services as part of being a licensor. People call us that we designed their unit 20 years ago, new operator. Oh, I didn't know, I'm new to the unit, I did something wrong, I need help. We help them out. If it's 30 minutes call, we help them. If they need somebody to go there, we send somebody over. Well, we send somebody over for a startup of the new plan that we design, but also we get a call for existing. I have one of my staff in Mexico this week. They wanted somebody go there. They all messed up with all their sulfur plan. They don't know how to start it up again. They don't know what the problem is. So we go there to see what the problem is, we check it, we analyze it, we test it, and we give them a recommendation what they have to do. Okay? As I said, we do all these services. I wanted to finish earlier so we can talk about all the questions you may have. As I said, the purpose of this presentation is not to teach you how to design a sulfur plan, because I don't want anybody to get bored or fall asleep or get tired. Because we as a company, because you work on different disciplines, but because we provide sulfur technology as a licensor, you should know what exactly this is all about. You may work on non-process, it's not in the process department, but whatever you do, I'm sure somehow you heard about sulfur or sulfur projects. Sometimes we only do license package, doesn't involve other discipline, but we do a lot of detail engineering also. As I said, 2 big Chevron projects, the majority of the work are sulfur. Sure. Yes, of course. We license Oxygen Sure technology, a very big one, because it's very complicated design. If you look at the control system that I went very quickly, we modified their control system that they have. Let me go back. This is if you have air operation, this is the way we do control system. Okay? Let me go to oxygen slide. You remember I told you that we do different level of oxygen? For all the levels, sometimes we don't need to go to split the oxygen. If somebody tells us I only need 30% oxygen or 35%, we don't need to add all this equipment. Sometimes we have to replace the equipment to the better refractory stuff like that, but sometimes we don't need to do that. For those, we go to 35 or 40% oxygen. You see the control system. This is for air. This is for single combustion. We call it single combustion when we go to the mid-level of oxygen. Mid-level of oxygen, it means we don't need to split the oxygen. We still can do with the same conventional configuration, but we may need to change the refractory, or we have to make sure the existing equipment can handle it. So for that, you can see the red part. You can see probably, I don't know, they didn't give you the color copy perhaps. The red part, you see, that's all we have to do. When we go to 100% oxygen, you see that we have multiple stages and multiple equipment. You see all the control system we have to have. This is a summary of those controls. When we generate drawing PNIDs, it's the entire drawing is all control. And we call it burner management system. And we describe how this control system works. one of the documents we did. Anybody's from an instrument group here? No? Yes? We work with our instrument department. Instrument engineer is under electrical group, electrical engineer. So the instrument engineer doesn't know how this control system works. We tell them what we're trying to do. We say, okay, we want to control this, we want to control that, we want to ratio this to this. We describe all those in writing. And we attach a copy of drawing with a number. We say, okay, this instrument has to be connected to this has to go this. He read our write-up, he go try implement it to the DCS of the refinery. And we get a lot of questions from them.